I never thought I would finally say this, but I actually believe what I have here is a free energy device. And what I'm going to be doing in this video is physically showing you the input and output variables that is being used on this generator. This right here is a little 3 to 5 volt induction motor that I took out of a pencil sharpener. And its purpose is to create high torque and high RPM, hence that's why it's used in pencil sharpeners. This right here is one that I accidentally messed up wiring. It was my first attempt, so obviously it didn't work out too well, but the polarities of each coil is going clockwise and counterclockwise every 5th phase point. So what I have going on here is something that I would call magnetic resonance. Basically, as the frequency goes higher, it starts tapping into the natural freestanding energy surrounding us at all times, and all that energy is coming from the sun. So first things first, we are going to need to figure out the efficiency of this system. So in order to do that, we are going to use the formula power output divided by power input times 100. And this is going to be before the load is put on the system. And then we are going to use the same formula to calculate the overall efficiency output after I have the system under load. And we are going to see if it stops the motor from turning. And if it doesn't stop the motor from turning, then what we have here is an over unity device. And it would also be proving that AI's perspective on this design, and my perspective on this design, is 100% mathematically provable. So now it's time to show you how I'm going to do it. So I have my voltmeter here hooked up to the input and the output of my single phase generator that you see here, the dodecatron. I have a 2.6 k ohm output for my resistance. Now, it gets a little bit more interesting. Here is the input that I'm using, which is 2 volts, 1.2 amps. All right, now I will show you guys the volts and current that this produces before it is put under load. Now, realistically speaking, if it's put under load, it should short out instantly. But if it's not, then apparently that's where I am gaining my efficiency, proving that this system has potential to go over unity. Actually, over 200% over unity. Okay, so these wires over here, don't stress about them. It's just my positive and negative connections going to the beginning and end lead of my single phase winding. And this is my series of 1 k ohm resistors, which equal to 5.6 kilo ohms in total. So this is what I will be using for the load. Now I will show you guys what happens when I hook the positive and negative to the DC motor and we turn on our power input. Alright, so we're at 110 volts right now. Now let's see what happens when we crank it up to 1.5 watts. Alright, so we got 132 volts, 131 volts right there. And this is before it's put on load. $23 milliamps. All right, now let's see what happens when I put it under load. Now this is the interesting part. Okay, so this is the interesting part right here. The motor is still turning while put under load. And it actually feels like there's still quite a bit of power in it. So this is my milliamp reading on the system while it's put under load. And let's see what the voltage reading looks like. I should have the voltmeter in series, actually. I read that amp reading wrong. But here's the volt reading. So it drops the system down to 22 volts. So I knew this was going to have some pretty intriguing results, but did you really expect it to perform this well? Now let's calculate it. To see what percentage your generator is running at efficiency-wise, you want to use the coefficient of performance equals power out divided by power in times 100, and that will give you the efficiency output. So for this case, before the system is put under load, the output coming from the system is 3.26 watts divided by the input, which is 1.5 watts times 100, and that gives me a percentage of 217% over unity. So after the system was put under load, the input value went from 1.5 to 1.1 watts, and you'll notice that I have to use the same formula to calculate the coefficient of performance. So for this, I would be using 3.26 watts divided by 1.1 watt times 100. And that would give me a coefficient of performance output of 296% unity. Or should I say, over unity. So for the next video, I am going to be using a higher torque, higher RPM, and higher efficient DC motor that will be using roughly 3 watts instead of 1.5 watts and hopefully create over 600% over unity when it comes to the coefficient of performance. With that output, I can take a fraction of the value and send it back into the input while still maintaining an output value that can be used due to the over unity value on the output from the rotating magnetic field. I thought it was kind of strange how AI used to be against this idea, and now it's all for it. So now I'm kind of wondering what's going to be happening next with these upcoming videos, because yeah, a lot of things have been changing in a very short period of time lately. So I'm very anxious to see this generator operate with the electrostatic motor, because I am able to use a high voltage DC transformer to power the electrostatic motor with only 0.3 watts. And it would be very incredible to see 0.3 watts take a 600% efficient system, or should I say a 296% efficient system, and send the power back into the input and harvest electrons from the sky. And for the last detail, what's very fascinating about this specific experiment is that there are no gears or pulleys. It is a one-to-one connection. So what happens if we use a higher torque, higher RPM motor and use a gear ratio on it to rotate the generator? Again, very anxious. That's all I got to say about that. Get ready to see my upcoming videos, everyone, because in the near future, not only am I planning to build an over unity motor generator, but I am planning to put it on a car and possibly a flying craft. So, stay tuned for more. Peace.